Hi everyone, my name is Charles Feddersen. I'm one of the program managers on the Synapse engineering team based in Redmond in the US. In the next 25 minutes, I'd like to provide a brief overview of Synapse. We'll look at some of the features, run through some slides for maybe the first 10 to 12 minutes, and then we'll break into a demo and give you a bit of a navigational tour around the studio and some of the key capabilities that are in Synapse Analytics today. Synapse itself is actually comprised of a number of different components. It's a single fully integrated service. When you walk up to the Azure portal, you provision a single service. I think the minimum number of pieces of data you need to put in 8 to provision the service. But it's comprised of a set of capabilities that enable you to build end-to-end analytical solutions. Everything from what you'd be probably most familiar with around those traditional data warehousing workloads, but also complex and very powerful data integration capabilities with support for hybrid data integration from other clouds or on-premises using code-free tools that I'll show you today. We put Spark, Apache Spark, into Synapse as well, so you've got that notebook experience and that engine for running workloads such as the complex transformations, even data science workloads, and really fusing that together with that more traditional SQL-based enterprise warehouse workload. And we encapsulate all of this in a new web-based development studio, and all of this I'll show you in the demo today. Now, if we step forward a little bit, I just talked about some of the core components within the Synapse service itself. Now, Synapse in of itself is completely open. We support a large set of what we call link services within Azure as well, where we leverage a lot of the capabilities in other services like Azure Data Share for data sharing, Power BI, and then Azure Machine Learning as well. I'll touch on a little bit in the demo, but also a very broad ecosystem of applications for data integration, data visualization, data modeling, that whole ecosystem of ISV partners. It's a very rich ecosystem, and they all work with Azure Synapse Analytics as well. So Synapse at its core is really enables you to simplify this solution building end-to-end without needing to go through that complexity of stitching together multiple services repetitively in what was traditionally that foundational analytics component, but then also gives you the hooks and the simplicity to bring in certain capabilities from other Azure services. And like I said, we call those linked services in Synapse, and I'll show you a little bit of that today as well. Now, before we break into the demo, I thought it'd be good to start with the studio and just provide a bit of an overview as to what that actually looks like. When you launch into the studio, you'll see that there's a very simple navigation on the left-hand side: data, develop, orchestrate, then monitor and manage. And this really, as simple as it looks, gives you access to all of your data in a very, very secure and governed manner. If I start by looking at, for example, the Data Hub, what you'll see here is it's a true data lake. Hierarchical files and folders that are accessible not just by the Spark and SQL engines directly within Synapse, but perhaps other analytics engines that you provision in Azure and you want to run a specific workload over that data. But for all of these engines, they can operate over that data in place. There's no need to export the data from one platform to bring it here. Synapse enables you to integrate directly with your data lake, but also blend it with fully managed data, perhaps in a SQL entity, and even write queries that join across both of those. And here you can see in the screenshot exactly what you'd expect from a data lake. Hierarchical file and folder system, of course, this is fully secured through Azure Active Directory as well. For those data warehouse workloads, of course, there's a SQL editor. You can see here actually in the develop blade, it's a bit of a nod to all of the development experiences. You've got not just SQL scripts, but authoring notebooks, code-free data flows for data transformation. You can see some Spark job definitions and even authoring Power BI, which I'll show you shortly. And at the bottom, you can see that we've built IntelliSense into it. Now, Microsoft has always had a very rich set of thick applications, client-side applications like SQL Management Studio, Visual Studio, and Azure Data Studio for cross-plat development. But this web experience is really the most rich SQL editor that we've released, and it's all part of that single Synapse Studio suite of capabilities. I just mentioned notebooks. This is what it actually looks like. So here you can see at the top, I'm connected to one of my Spark pools, as we call it. You can think of it as a cluster, and then you've got a language that you selected. It's a very simple piece of code here that just brings back the top 10 records. But again, it's demonstrating how you've got that full fidelity of development all in a single holistic place, as opposed to jumping between a whole lot of UIs and really a whole lot of cloud services to build an end-to-end solution. Code-free data flows enable you to build transformations where you can source some data, run it through a set of transformations, and then put that into a sink. You might be joining data, and this data could be coming from within Azure, of course. It could be coming from on-premise data centers, and we do that securely through what we call integration runtimes, or even pulling it from other clouds, or actually even just cloud-native applications, like SaaS applications, if you will. And so the power here is that it's completely code-free, as you would expect with an ETL tool. And what we actually do under the covers when you run this is we boil it down and run it on, or still compile it down to Scala actually, and then run it on Spark clusters directly within Synapse. So we think of this as code-free transformation at scale. And for anyone who's sort of built on legacy ETL platforms, perhaps on premises where that was a limiting factor of scale, this gives you the ability to scale these data processing and transformation jobs out without the complexity of figuring out the code for that. But of course, then you can actually augment this and overload it with some of your own code as well. And then I mentioned authoring Power BI as well. And so here you can see an example. The nod to the fact that we're still in Synapse Studio is those icons down the left side, data, develop, orchestrate. But we've taken the web-based experience for authoring Power BI and brought this into Synapse Studio as well. And so here you can imagine that analysts might have done some data manipulation in SQL, maybe data scientists have done some work in Spark, and now they want to visualize these results. You can snap over to Power BI in the same experience, turn that into a rich set of visualizations, and if you just click the little save button in the top right, that'll propagate that to Power BI. And of course, actually Power BI also has a very good integration with Microsoft Teams, which is possibly useful for a lot of the remote work scenarios that we're working through right now. Now, a couple of features that we launched just recently at Build I wanted to spend some time on quickly. One of those is Synapse Link. Now, I've spent a lot of time on enterprise data warehouses over the years, and one of the challenges has always been, or I think not so much a challenge, but one of the most mandatory components of that solution was building ETL jobs, building data integration jobs from operational systems and bringing them into the warehouse or the analytics platform. And absolutely, this is still a key component, if you just showed it with the data flows. But in situations where that operational system and the analytics system resides in Azure, we can do actually something a little clever, and we call that Synapse Link. With Synapse Link, we remove the need to build data integration pipelines. Instead, just by selecting a simple checkbox, today in Cosmos DB, you can actually automatically index that operational database into a columnar format without any impact on the operational system and make it available and kept up to date with latency of around 30 to 60 seconds in Synapse. And so I'll show you what this looks like in a second in the demo, but it's really, really powerful because you can think about having Cosmos DB running an operational system and really high throughput and low latency and exactly what that platform's built for. And by simply enabling a checkbox in the Azure portal, a few minutes later, that data is indexed, is in a columnar format, it appears in the Synapse Studio. There was no impact to that operational system in running that indexing. And then we automatically keep it up to date, all inserts, update, deletes, all changing data. And you've effectively got this source of real-time operational data directly available in Synapse, where you've also got your enterprise data warehouses, your data lakes, and any other data that you might be doing analysis over in the system. So it really simplifies that integration and that timeliness, the timely delivery of operational data. Something else we talked about was lighting up the predict keyword function in the SQL engine of Synapse. What this really solves is that the long-standing challenge of operationalizing machine learning models where the data lives and providing that scalability of effectively in-engine scoring without taking a dependency on external services, perhaps through your REST APIs where you need to pass records out to score them, which is going to have some scalability challenges with the response rates and latency you would expect from an enterprise data warehouse. The way we implement this is we use the ONNX runtime. ONNX stands for Open Neural Network Exchange. It's sort of, think of it as like an industry standard representation of ML models. And it actually does a couple of things. First of all, I mentioned we run the ONNX runtime in engine, so you get the scalability as the cluster sizes change. But the other nice thing about standardizing here is that if you look to the left around that create models box, there's a whole lot of applications. SAS is actually another application that's not reflected here that can produce and convert either natively or convert models to the ONNX runtime. You know, for data scientists, they'll often use the tool of choice. It might be a tool they're familiar with. And although Spark itself can also produce the ONNX runtime, there are other applications that might be in use. By using ONNX, we effectively enable this common interface that a multitude of different applications could be used, produce a model in a standard format that we can then operationalize securely with all of the governance and rigor in our enterprise data warehouse and invoke that model co-located with our data in the data warehouse. And then by putting it into SQL, which is really probably the most ubiquitous language for analytics, it makes it very approachable for anyone to leverage that model. And I'll show you actually in the demo how we can take that one step further and put this under a database view and completely abstract from the user the fact that there's any predictive analytics or scoring going on in their SQL query at all. So with that, let's perhaps flip over to the demo and I'll start to make some of this real. So here we are in my build workspace now. And as you can see on the left-hand side, everything that we just looked at in the slide. So data, develop, orchestrate, monitor, and manage. And so I'm going to start the data blade here. And what you're going to see is I've got my storage accounts here. So these are all of my data lakes. I can bring this open to show that I've got some Parquet data available to me here. And then down here, you can see I've also got Cosmos DB. I'm going to come back to this one in a second. The first thing I'd like to point out is I can right-click on a Parquet file and I get a set of navigations or a submenu here that I can launch a whole set of different analytical experiences. I could go directly into a new SQL script. I could launch a new notebook. I could create a new code-free data flow of this, or I could spin it into a reusable data set as well. And so, for example, if I took the SQL, I could say select top 100, and I launch a new tabbed experience where I, by default, connect to SQL on demand, which is the pay-per query form factor within Synapse, great for data lake exploration, those relatively ad hoc scenarios over the lake. Also really good for doing conversions in the lake. If you've got files that are landing as delimited and you want to convert them to Parquet, it's really easy to do that in SQL, in SQL on demand as well. But if I come back to raw files, the thing I want you to remember is those top 4 elements. I'm in my data lake and I can launch a set of analytics experiences. At the moment, I'm on my linked services, but if I come back to my native workspace where all my enterprise data warehouses are, I'm just going to open this predict DW data warehouse, which we're going to use a little later for another demo as well. And when my tables expand here, I'm just going to take any one of these. Let's take trips 100,000. And what you'll see here is I've got parity. New SQL script, new notebook, data flow, and data set, the exact same as the submenu. And so this is where we're really sort of creating that or blurring that separation between the data warehouse and the data lake. And what's interesting here is if you think about how you may have done this in data warehousing previously, those tools were very SQL focused. That was the nature of the workload. But in this scenario, if I'm a data scientist and I want to launch from my data warehouse directly into a notebook, that's no problem. I'm selecting directly off a table in my data warehouse. I can load that to a data frame. We do a little bit of code gen, I can run that cell and I'm off and running. And so a really efficient way and no need to have a separate services for each of these capabilities where you may be moving data back and forth or moving it to a data lake simply for synchronizing between platforms. I'm going to close that one. Now let me come back to where I was in my linked services and you can see I've got a couple of other things. Here's my Cosmos DB. The little icon down here is the giveaway. So imagine on the back end, I've got Cosmos DB running and perhaps it's powering a website application or something of that scale and that very low latency that Cosmos is known for. Here, this data is going to be only seconds out of date and continually kept up to date as changes are happening in the operational system. I've not built any pipelines. Synapse Link is doing everything for me under the covers to maintain this for me. I can expand this out And if I click here and select new notebook, you can see I've also got some choices. And so I'm going to take new data frame here. And again, you'll see, let's close that out, that we can launch directly into a Spark experience. And if I was to start then iterating over this code, you can see we've got a native format called cosmos.all. And I could run this and it's going to pull, like I said, data that's only very recent. And if I'm using Spark for machine learning, this becomes kind of interesting because now I've got data that's automatically being kept up to date under the covers for me. I can train and then potentially subsequently retrain my model over the freshest data, maybe even multiple times a day, and very easily operationalize that in Synapse, as I'm going to show you shortly. Let's close that one and now flip over to the develop side. So we've got a set of scripts that we built already. I'm not going to have time to get through all of these today, but there was a couple of things that I wanted to showcase in particular. The first is around the predicting engine scoring. And so here you can see I've actually got a table that's got my model in it. And let me just close this so we've got a little more room to see the code here. And I have a table called trips. The trips table has about 4,500 records in it. I can just run this quickly. I'll show you the messages, 4,655 records in that table. And what you can see here is that there are 7 columns, vendor ID through day of hour, or should be probably hour of day. I need to go change that. Let me scroll down a bit and show you what I did here in this next query. This query is actually going to select the top 10 from that table. And I've added a total amount column, which you don't see here. And that's because total amount is going to take an Onyx format model from the models table. It's going to plug into it the 7 columns from trips right here. And it says the predicted column, the score coming out of that model, is going to be called total amount. And I can go run this. And what you're going to see, it comes back very, very quickly. And this total amount, this is actually a predicted value. So this is not too bad. This is pretty simple and pretty approachable for SQL developers. Now, if I scroll down a little further, however, let me show you how this scales. So here I've got a query that does a few different things. First of all, I'm using predict again. I'm passing in the same model. But taxi trips here, 5 million. This is a table with 5 million records in it. And I'm running a relatively small cluster. I think it's about 1,500 units in size, so not large at all. But what you can see here is when this column comes back, I'm then also doing some work with SQL. I'm going to put a SQL average on it. Then I've got an outer query here, which is actually putting a windowing aggregate rank over that trip amount as well. And then I'm grouping it by the passenger count and ordering by the passenger count as well, or passenger count, trip account as well, right here. So let me go run this. Oops, lost it there for a sec. I'll run that. And so here we're running our prediction over 5 million records and rolling it up. Now you've got there are 2 ways you could do this. You could aggregate the data first and then score it, or you can score it first and then aggregate it. And you would get slightly different results, of course, for each, and maybe different ones are applicable. But what you've seen here is that in 12 seconds, I've been able to go and run a score against 5 million records, so 5 million individual predictions, 1 per record. And then I just rolled it up into this average here, and you can see my stack rank on average trip amount showed that this here must be in a descending order. This must be my most expensive average trip amount. So again, really simple way to not just get access to running the Onyx model through the predict keyword in SQL, but also with fantastic scalability that I can run 5 million predictions in just 12 seconds. But let's take this one step further. What I did then is I went and created a database view. And so here I didn't do any aggregates or anything. I just said, I want to create a view over basically that first query that I showed with the 8 columns, plugging in the predictive model over those taxi trips of 5 million records. What this means then is now I can just run select top 10 over this view. So let's run that. Without any dependency on the keyword predict, I can now bring predictions directly into my data. And this is powerful because now we've basically democratized predictive analytics to any BI tool or any user who understands basic SQL. Right? It's fair enough that people may not understand the nuances of the predict keyword. It's not particularly mainstream SQL, and maybe we wouldn't expect our analysts to nail that. But now you can actually just put it under database view, and except for the fact that you would need to tell them, there's actually no awareness at all that a database view is being deployed here, or a predictive algorithm, I should say, is being deployed to generate this value. Now, if you think about operationalizing that, how can we bring all of this together? So for that, I'm going to jump down into Orchestrate, and I have some pipelines here. And here I've actually got a hybrid file copy that I started earlier. But let's imagine actually, I'll move that down, that I wanted to actually operationalize that. I wanted to bring some data in, and perhaps I'm copying data from one of my source systems. And then I've also got this real-time data through Synapse Link that's coming in. And actually periodically, perhaps every time on a schedule, or maybe when a separate file lands, I want to go on operation. I want to retrain this model. Super simple. First of all, I can just bring out my Synapse notebook. I won't go through the intricacies of wiring up exactly the predictive notebook, but you can see how that would happen right here. And then actually what I need to do is run a SQL store procedure to initialize that model into my data warehouse. Also very simple. We'll put that there and drag the arrow here. Now I could go ahead and schedule this by adding a new trigger. I could click new, and maybe I schedule this on a periodic basis. I could use a tumbling window. If I had files just continuously landing into my data lake, I could use event-based notifications as well. So when that file lands, this whole workflow will load. And this is not just loading directly into the warehouse, but it could be a complex orchestration that does a number of things, such as retraining models in Synapse, initializing them. Maybe we're calling out to Azure Functions for something else as well. But I could run all of that. I won't do it right now in Synapse as well. Set this up to run. And then automatically that Synapse Link data is flowing through. Maybe I'm updating my ML model in the database 4 or 5 times a day. It doesn't really matter, because for my developers, all they're seeing is this database view that I showed at the bottom. And the model's just a new updated model's being pushed in consistently under the covers. And so you can see how this really simplifies that operationalization of ML models built on Spark or other applications perhaps, with that real-time data from Cosmos DB, or perhaps other sources that I've pulled in through my code-free pipelines. So to close with that, I should show you code-free pipelines just quickly. If I come back over here, you can see I've got some code-free pipelines that we've used previously. Here's one that's a little more complicated than we showed on the side. We've got some raw customer data. We're doing a join here and an aggregate. If I want to add a new source to this pipeline, who knows where it's coming from, I can select new right here, and you can see a whole set of sources that are probably pretty familiar. There's a lot of Azure sources, there's other clouds, other database technology, FTP as well. So a whole range that you can bring and implement into your code-free pipelines. And then finally, I mentioned that you can author all of the outcomes from this with Power BI. And so I've got a report for Power BI right here. And here's just one example that we built earlier. I'll just close out some of these to give it a little bit more real estate. And all of this can be built on the ML that I produced with Spark, operationalized through SQL to produce a rich dashboard that I can publish out to Power BI. So that's probably everything we've got time to demo today. I'll just move this back over here. And perhaps at this point, we can wrap up and take some questions. Thank you very much for your time.